And it's also I know. It's a big what?
So, all right, okay. Hi everyone. What's on the agenda today is we keep implementing abstract data types, and we keep doing it in Python. So where's the file name? Okay. So first, I want to do a little bit more of kind of fun Python syntax for classes. So to remind people, this is what something like this would look like. So let's say like acorn entry or something. So unlike in C, we do not predefine the elements of the class. We could add those later on, but we have this special init function, which basically does the same thing in that it doesn't have to take any arguments, right? Again, it could just be self, and you just say self my mark is 100, and you get to do that. It's not at U of T, but in general, right? So that's completely fine. It's just that that's not how you would use init, but you could, right? So I can say like acorn is my acorn entry, and what's going to happen is init is going to get called, and this new acorn that's being created is going to have a dot my mark equals to 100 completely, right? So I run this, then print it. But if I print acorn my mark, it's going to be 100 because I set it to 100. And that's the same kind of thing as also me being able to say acorn, whatever I want, your mark. Sure, that seems reasonable. And now you can print that as well, and that would print 2 in U mark. And it would print in exactly the same way. And they're treated exactly the same. It's just that one happens to be set up in init. Now, the way you usually use init is not for this kind of silliness. It's for actually setting up an object where all the objects are roughly the same. So sometimes, I haven't done it this year, but if you remember when we wanted to have functions that remember stuff and we used global variables for that, the other way to do it is to say like f and then like f.mem, again, just like an arbitrary thing, you can say is equal to x, and then you can access f.mem kind of across calls to f. And the reason it works is exactly the same reason that acorn.yourmark works. You can say anything.anything. All right. Does that all make sense? Yeah.
So for a function, you can also have these like variables or properties. I don't know what to call it.
Attributes, yeah.
Attributes.
Yeah. So in Python, they're called attributes. And again, kind of a function is an object in the same way that an acorn entry is an object, and you can add any attributes unless specifically disabled. So for lists, if you remember, that did not work, but that's special. Most objects, you can add whatever attribute you want whenever you want it. So just to complete the example, just because so I can say like current entry, or current argument, I guess. and that would be X. And I can say previous argument is f.mem, and now f.mem is X. And now I can just repeatedly, after I say f.mem is something, because if it's nothing, that's a problem. So there is a way to get around having to do that as well, but not going to get into it. And now I can do like whatever f10, f20, f30. And that's going to work in exactly the same way that it worked when we used global variables. So essentially, f.mem acts here as a global variable. And the reason is that f is a global variable, literally, right? The function f is a global function. So f.mem is just an attribute of f that you can add, and it just acts like a global variable does. Right? So that's not super important. This is just to illustrate the point that you can have attributes for anything, and that is what init does, right? So init just sets up attributes. Now, the usual way you use it is not this. The usual way is you tell it, okay, so I'll give you the course, for example, and I'll give you the mark, and you'll say self.course is course. Those do not have to match. It's just that because they mean the same thing, it's natural that they'll have the same name, right? But self.course is the attribute of the acorn entry. Course is just the local variable that also happens to be named course. It's just that, well, if they're the same thing, well, they would probably have the same name. But as far as Python is concerned, those are separate. And similarly, I could say self.mark is equal to mark. So this is stuff that we've done before as well. So I can do something like this. ESC190 is like the arts and science 180 kind of. So stands to reason that that's 100. So on the other hand, 180 is harder. So that's like a 90. Okay. No, just 8. Okay, so okay, so here, of course, so this is artsy, something like that. Okay, so what happens when acorn entry gets called? Well, init gets called, acorn entry gets constructed, it's not exactly called. So init gets called, the self is the new object that's got to be returned. And then you say the attribute of course is dot course, the attribute of the course is dot mark, and then acorn artsy has this dot course, this dot mark. Yeah. All right. So, okay. So another mechanism that I want to discuss now is it's called function and operator overloading. And that is defining what conversion, how, for example, right? So we have an idea of how conversion to string works for integers. It becomes quote 445 quote. But you could imagine that it would be different, right? You could imagine that you're instead presenting it as binary or something. Right? So it's not kind of necessarily set in stone. Maybe a more natural example, like you could imagine that something like this would be actually like all the digits. or that it would be presented in science. This might have been too many digits anyway, or that it would be in scientific notation rather than presented like this, right? So there are options about how you convert to string, right? So similarly, anyone would say that 5 smaller than 10, like that's got to be true. That's what smaller than means. But what does it mean to say ABC is smaller than ABZ? So that is true, and that's because ABC comes before ABZ in lexicographic ordering. So like in dictionary order, one comes before the other, but that's like obviously a little bit arbitrary. You could just say, well, you cannot compare strings, right? Or you could say it's going to be in dictionary, in lexicographic order, literally like a dictionary, and that means that case doesn't matter, that uppercase A and lowercase a wouldn't be different. For Python, they are. Right, so there is options about how you do those things, is the point. So for acorn entry, so for objects like acorn artsy, acorn anxi, none of those are defined either, right? So let me read this in. So I'll do a tutorial at some point on how to do like the Paizo shortcuts. In the meantime, I'll just copy and paste. So now we have acorn artsy. I think those were defined. So now I have acorn artsy is like this. And that obviously does not display anything that really makes sense. It just says it's an acorn entry. But in principle, I could specify how to actually print it when I am asking for the value. So the way you do it is you define this function repr for representation. And yeah, like you can do something like this, right? So you can say like acorn entry. Well, let's not do it. So let's do it. Self dot. Or so the mark in is self.mark, and we'll do it as an F string. Yeah. All right. So what this does is basically there is a default wrapper that outputs this thing, which is not super readable, but I can define my own wrapper, which overrides the wrapper that made this one, and is now whenever print is calling wrapper, which is what print does when it tries to print the object, it'll just call wrapper with the self acorn entry, and it'll print this. All right. That's assuming that the syntax is valid. So line 1. Oh, that's because I'm in, so. So now I can say print acorn artsy, and it printed this. All right. And that's because what print does inside when it prints an object like this is it has a default wrapper, a default string representation, but if there is another wrapper that overrode the default one, that's what's going to get called. So now when you print acorn artsy, it looks like this. Make sense? So that's kind of cool for printing, but you know, so okay. So another thing you can do is you can do comparisons. So this is LT. LT stands for less than. And you can define how you would compare a self that's an acorn entry to a different acorn entry when you use the less than sign in your code? And the answer is you'll call this function, and this function would, for example, return true if self.mark is smaller than other.mark. Right? So if we define that, now we can say, is it true that acorn artsy is lesser than, how do you spell this thing? Is lesser than acorn anxi? And it's gonna be false. It's okay. So we'll fix it. So now that's true. The way it worked is we said, okay, so we're so acorn artsy less than. That means that we're trying to compute something to do with less than for acorn artsy, which is an instance of acorn entry. So that means that LT is going to get called. And LT is going to say, well, self.mark is smaller than other.mark. So I'll, in this case, return true. You could do something more complicated. So you could say, okay, so you have the course and you have the mark. And maybe what you want to do is you want to sort. And in fact, you'll do that in the lab later today. Right? So you want something like ESC190 90 and then ESC180 91, and then because it's by course and then by mark, and then it would be like ESC190, and that's gonna be something like this. Just for the sake of the example, let's make it lower to make clear that it's not sorted by mark, just by course and then by mark. And then something like this. All right. So in order to make this work, what we'll do is we'll define an LT function that makes it so that if we want the entry to be earlier in the order, then it's going to be smaller. It's going to be larger if we want it to be later in the order. Right? So how can we do it? Well, so kind of the straightforward way is, well, Copilot knows, but the kind of more straightforward way is to say, well, like if self course is smaller than other course, then we return true. And then if it's equal, then we look at the mark, right? So if self.course is equal to other course, then whether it comes before or after depends on the mark. That's the only situation where it depends on the mark. And otherwise, we return false. So the shorter way that Copilot was suggesting before is we'll just make tuples out of them, and we'll compare the tuples, and Python already compares tuples this way. Right? So we'll just say return, self-course, self-mark, smaller than other course, other mark. And it so happens that this is how Python compares tuples already, right? So if you compare, so is this smaller than this? No, it's not, because 5 is actually larger than 4, and it compares 5 and 4 first, and then it compares 6 and 10. It works kind of the same as comparing strings, where first you compare the first letter, and then if there is a tie, you compare the second letter. If there is a tie, you compare the third letter, and so on. That's exactly what it does with tuples as well. So you can kind of avoid having to write this if-else thing if you just construct those two tuples and compare them. That's what you want. Make sense? So, okay. So now that we have this, we know, well, I'm telling you now that what Python's sorted function does is it just uses less than inside of the sorting and equal. So we need to, so equal actually is not necessary. So now that we have LT, we can just define a bunch of entries. So for example, those ones, and try to sort them. So I'll say like entries is like this, and it's gonna be whatever acorn entry. How many people are typing without Copilot? Why? Okay, I'll type along with you, but please get Copilot. It makes a lot of sense. So ESC190 90. And then I'll do acorn entry. I'll do like ESC190 and then 87. And I'll do ESC180, 100. And I'll do acorn entry. ESC190, 89. Right? So this is a list of objects, just like you could have a list of strings, and you might like to have it sorted, right? And we will sort it. So I'll just say entries.sort. And I'll say print entries. That's not actually, we'll see. So that's going to be like this. So this I don't want to print anymore. And here it is. Right. So first the ESC180 marks, and then the ESC190 marks sorted in increasing order. So in a way, this is kind of analogous to qsort, where you provided a comparator function to compare the elements, right? So here, instead of providing the comparator function, you define the less than method. Yeah.
Why do we need the underscore around the function?
That's just the name of it, right? So in the same way, so the question was why the underscore, and the answer is that the name of the thing that gets called when you're creating the object is underscore init underscore. That's just the name. The reason the name is like that is to distinguish functions that you make from functions that are kind of built in. Now, as far as like Python is concerned, like the only reason that LT is different is, well, underscore LT, I should say, is that that's the function that Python calls when it sees the less than operator, right? Otherwise, it's like you can call it yourself if you want, right? So there's not a problem with saying, for example, like entries 0 LT entries 1 or something. And that would be just the same as. Right? So it's a function like any other function, except the less than operator is connected to it. Yeah.
It's pretty rare. Is it true that under the hood strings are subject tuples? Or sorry, strings are tuples of characters, and also with tuples of pattern?
I mean, like they're similar, they're not literally tuples. Yeah. Oh, okay. Good stretch. Okay, all right. So okay. All right. So that's like that. So anyone else have questions, want to stretch? All right. So I think it's pretty straightforward. Like you obviously, like I don't think there's anything complicated there. Obviously, kind of when you're seeing it the first time, I think it's a little bit of material, but like all it is less than means you're calling LT. Print calls wrapper when it wants the representation of the object. That's what we've learned so far. And you can define your own custom LT, your own custom wrapper. So one thing I will say is like you can say, and that's probably like, well, no, like you could. So you could say, well, like I actually want to sort by mark first and then by course, right? And the way you could do it is, so by the way, there is a way to also provide a custom comparator to sort, but you can also say, well, I don't want LT to be like this anymore. I actually want I want it to go the other way, right? So I want to compare mark first and then course. Right. So now the less than works the other way. So if the marks are equal, then you compare courses. Otherwise, you just compare marks. And if you print it out now, so we're printing again the sorted version of this. So this would be sorted by mark first and then by course. In this case, it's not super interesting because there's no ties between marks anyway. So let's make one tie, I guess. So let's make this be 90 or something. And here you are. Now it's sorted by mark. And if there is a tie, then it's sorted by course. Makes sense. So let's now move on to another example. And that's going to be in the lab today as well. So want to make a Q object, objectivity. No. So first of all, what's a Q? First in, first out. So Q, like in North American English, more commonly known as a line, I guess, but like you do queue up. So like the first person who stands in line, who gets to the cash register in the grocery store is the first person who gets to check out. Right. So that's the idea with first in, first out. If you got there first, you would get out there first. So this is unlike a stack, which is last in, first out. So it would be, like if the last person to get to the cash register is the one who gets to check out first, which is not how stacks work, or not how queues work. So, okay. So, so let's say that I want to do that. So, and let's say that for now, I don't really care about complexity. And I'll just implement it as a list, right? So the idea would be, like if Q is 4, 5, 6, then basically what I do is I'll officially do it. So we have on Q, add an object to the queue, DQ, remove the first object in line from the queue. So unlike with a stack, that means that we got to add and remove from both sides, right? So you could, for example, say that you'll insert at 0 if you are unqueuing. So like you want to unqueue 7, that would be like this. And then you'll remove from the end. So you dequeue 6, that would be like this. Sorry, is that questions about what the queue is? Like let's do like a very quick example. So let's say that this is the queue. We do unqueue 10, then the queue would become this. Right? We do a dequeue, and the answer is 5 because 10 got their last, and the queue becomes this. So 5 got removed from the queue. We do another dequeue, that would be a 4, and the queue is now just 10-7. Yeah.
If we're looking at this like a grocery store line, 5 is.
First in line.
5 is like
Yeah.
up check.
Yeah, exactly. Yeah. Does that make sense? Yeah, so 7 for 5. So 5 is first in line and 7 is waiting. So of course you don't have to. So I represented it as a list because I got to represent it somehow, and I will represent it as a list. Here, you don't have to make it a Python list. In fact, we'll analyze it for complexity and we'll see that that's not ideal. So just like with stacks, actually, it's better to use a linked list, for example, in some situations. And with queues, you'll see some more fun options in the lab. So, all right. So by the way, so just by convention, classes are named with capital letters. That's just a convention. So, all right. So init is going to look like this. So initially, queue is just empty. So if I want to unqueue an element, then so the way I described it is I actually want to insert in location 0, right? If I want to dequeue, I get to use pop, and that's kind of why I chose to make it so that the queue ends at the end, is so that I can dequeue easily by just doing pop, because that's exactly what pop does. It removes the last element and returns its value already. So I don't need to do anything extra there. So I can define all sorts of functions. So let's say I want to print my queue. Well, I could do it element by element, or if I print the default, it'll just say, well, it's a queue object. But I can also do a wrapper thing. So here, I think, like, what do you want in the representation? I think you kind of want just the array the list, sorry, self.queue. It's kind of self-explanatory, except it doesn't say where it starts and where it ends. So I could do something like, well, I guess like what does it mean for a queue to start and end is also kind of ambiguous. So I'll kind of say last in over here, and then I'll do the self queue. And I'll do a first in here. So just because like I think it's a nice way to represent it. Maybe you can think of a nicer way. All right. So now that that's created, we can create our own queue. The small queue is taken, but I'll call it like Q1. And I like unqueue. So if you don't have, well, I guess like you should have at the very least autocomplete so that you don't have to struggle with unqueue, which is like not easy to spell. You have to practice for the exam though. So we unqueue 20 and let's dequeue something. And let's unqueue 5. Right, so what do you expect? You expect a queue where 10 was waiting, but then got dequeued, and now 20 is waiting, and 5 is second in line. So if you print Q1, that's what it's going to look like. Make sense? Questions? All right. So just to remind people, kind of the whole point of doing this kind of thing is that Q, technically, of course, there is like a library as well, but the point is that you would be able to reuse it. So in the same way that in C, you can include something that's a queue, in Python, you can import it, right? So generally, the way it would work is you'd have another file, and that file would be useQ. No, that's still Q. Right. Confused. Oh, okay. Yeah. Yeah, we're over here. And rather than having class Q over here, I'll do like import Q. And then this would be like Q.Q. Right, so that's the Q.py file that contains this guy. And then I import it and I just use Q as much as I want. That also opens the possibility that you'll explore in the lab today of using Q in different kind of with different implementations, right? So you could imagine that one file Q implements it one way, and then another one implements it another way, and you just choose which to import. And as long as they both have unQ and DQ, this code doesn't care about what the exact implementation is. So the last thing I want to do is I want to analyze for complexity Q.py. So what's the complexity here? Well, it's not, so you have to kind of guess what insert has to do, but insert basically has to move all the elements in the queue, right? So if Q had been whatever, then in order to insert a 50 here, what you needed to do is you needed to move all of those elements one space to the right. So that means that this is O of n, where n is what about this? Anyone? Yeah.
I guess O of 1 because you know the position of the last.
Yeah. Yeah. And Copilot got there before you, but I think you started answering before it figured it out. So yeah, like the text wasn't there, I think. So okay, you and Copilot agree, and you're correct because you are not really, so it's not so much that you know the location because it's just the list. So all you need to say here is, well, the list used to be n elements long, and now it's n minus 1 elements long. Don't need to do anything else. You might need to clean up the memory that was being used by the one element, but that's also one because you're cleaning up after one element, right? So if you're thinking about it in C, it's like literally all you need to do to remove an element from a C array or a block of memory is to say, well, the block of memory used to be n long. Well, now it's n minus 1 long. That's it. I'm done. Right? You literally don't do anything to the element by default. So that is O of 1. So one possibility for achieving O of 1 for both onQ and DQ is a linked list, right? Sorry, so actually idea 0, if you care more about onQing than DQing, then there is no problem making it so that it's onQ that's O of 1 and DQ is O of n, right? Do people see how? Anyone? So like something very simple, yeah.
You just reverse the list.
Yeah, exactly. Yeah. So here the reason it's O of n for onQ, sorry, is that I got to move all the elements and put the first element at the new position 0. Well, I could instead do by just using append. Append is O of 1. And then O of n for DQ using so pop 0 actually works. So pop by itself removes the last one, but you can say pop 0, and that'll give you the value at index 0 and remove that element. Yeah.
Would pop 0 be O of 1?
No, it would not, because of the same issue. You got to move the entire list one space to the left. All right. So, all right. So like you could imagine an implementation of list, which does work like you suggest, where you just move pointers. It's just like not what happens. Okay. So idea 1, if you want O of 1 for onQ and DQ both, is linked list. Right? So that's going to be like A, B, C, D, E or something. And to onQ, add, let's say, to the end. And that's O of 1 if you keep track of right? So if you keep track of like what's my current last end, and you know it's E, then appending is O of 1 because you just need to do E next is a new thing. And then to DQ, And that's of one if you keep track of the head node, which you definitely do because otherwise you don't have access to the linked list anyways. Yeah.
What I'm wondering is, back to the node at the end. Don't we then, like, we don't have a pointer that points back. So how, don't you have to cycle back to the whole thing?
Well, I mean, you would if you don't keep track.
What I'm saying. Like,
Sorry, so
see what I'm saying? So like,
yeah, so you mean like the node before last, yes.
we ever link this one to left and right is, check out someone
Yeah, so for the, so you would have, so for that, so you would,
Can't go.
so you would need a link back to every node,
So then that's, so should, see what I'm saying here?
Yes, so you would need, so it needs to be the case. You're right, and thank you, and we'll do it when we do it. So needs to be doubly linked. Well, so it's just not just that you have a next, you also need to have a link to previous. Right, so we're not doing it right now. So the other idea is called use a circular list or circular array. And the idea is kind of like this. So, and you'll do it in the lab, some of you extremely soon. So basically your current queue is like this. And then you append to the end. So you can add a new thing here. And you can remove stuff here. And you keep track of the last and the first index. Now, the problem with this is like you keep unqueuing and dequeuing, your thing keeps shifting to the right. So what you say is that if you are at a point where you ran out of space on the right, you just wrap around. So to insert Y, so that would look kind of like this. So eventually you're gonna run out of space and need to, just like with array list, you'd need to increase the amount of space that you have in total. But for a while, you can just keep until you fill up the array, and any array-based implementation is gonna have trouble like that. You can just keep going, and then it shifts more and more to the right, but that's okay because you wrap around if you run out of space on the right. Make sense? Yeah.
If that's the case, then why don't we just use a circular link list?
You could. So a linked list is kind of more expensive on a per element basis a little bit. Going through it is a little bit more expensive. But yes, like you could. All right. So all right, and it doesn't need to be circular. Like the idea with a circular array is that you're running out of space. So a linked list, like you could make it circular, like you could hook up the end and the beginning, but there wouldn't necessarily be a point. Yes.
Can you clarify what a circular array is?
So a circular array is this idea where if you run out of space on the right, you just wrap around.
So if you just start overriding and you're not like insert elements in the
I mean, you can do whatever you want. It's an array. You just say that if I'm getting out of bounds on the right, I'm wrapping around and starting filling it in on the left. Like that's all there is. All right, okay, I will see you. Thank you very much.